Our last examples from section 6.8 on exponential growth and decay models are on decay. The amount A of a radioactive material present at time t is given by this function A of t equals a sub 0 times e to the kt, which should look very familiar. We had n of t equals n sub 0 e to the kt for growth, and honestly it doesn't matter if you use a's or n's, it's the same function, so I wouldn't worry so much about that. A sub 0 is the initial amount, and K is a negative number that represents the rate of decay. Remember, for growth it was positive, so that's the only real difference, is your K is going to be negative. Note that all radioactive substances have a specific half-life, which is the time required for half of the radioactive substance to decay. So look at example 3. We have a radioactive material, iodine-131, and it decays according to this function, where A sub 0 is the initial amount present, and A is the amount present at time t. T is in days. Assume that the scientist initially has a sample of 200 grams of iodine-131. Okay, what is the decay rate of iodine-131? Well, we see it from our function here, that K equals this number, negative 0.087. So the rate is a negative 8.7%, right? The rate, it's a decay rate. So if we say the word decay, we don't need to put the negative, right? If you're saying decay, it decays at a rate of 8.7 cents. That implies that it's negative. So this is a decay rate. Or you could, the negative implies a decay, or the word decay implies a negative. How much iodine-131 is left after 5 days? Find A of 5. Well, the scientist has 200 grams, so that's A sub 0, times e to the negative 0.087, and t is 5. So this is just a calculator problem. We have 129.45, or approximately 129.5, and this is in grams. So after 5 days, we've gone from 200 to 129.5. When will 100 be left? In other words, when have you reduced by half how much you have? That would be the half-life, the time it takes to get to half. So let's find out. We're down to 100. We start with 200. What is T? Divide by 2. Change it to an exponential. Change it to a log. It is an exponential. So it's log base e of 1/2. So t equals the natural log of 1/2 divided by negative 0.087. And we get 7.967, or approximately 8 days. So that would be the half-life. If you start with 400 grams, then you would end up with 200 in the same amount of time. That's the time it takes to reduce this to 1/2.